Hey everyone, Teacher Chang here, and today we're going to talk about a new conic section, and it's on parabolas. I'm just going to read this over here. It says the set of all points. A parabola is the set of all points in a plane which are an equal distance away from a given point, and that given point is the focus, and a given line, which is called the directrix of the parabola. So what we want to know is, well, what is the focus? Well, the focus point is this point over here in yellow. So we have that focus point right over here. Okay, so here's our focal point. And then we have something called the directrix. And the directrix line is this point over here. Or it's this line. So in this example, the directrix line is located at y is equal to -1. Now, what this definition is saying here, it's saying that if we pick any point on this parabola, we will go ahead and find the same distance from that directrix as it is with that focal point. So what I'm going to do is I'm just going to pick a point on this parabola. It could be any point that I want, and I chose this point for a specific reason, because we could see that the distance from this point straight down to the directrix is going to be 5 units away. And according to this definition of a parabola, that means the distance from that same point to the focus, or to the focal point, is also going to be 5. So the distance from here to here is also 5. That's the definition of a parabola. So any point on the parabola is going to have the same distance from the focal point to that point on that parabola as it is going straight down to the directrix. So let's go ahead and take a look at some examples, and we're going to go ahead and try to graph some of these as well. But before we do that, let's take a look at some of these characteristics. And the main thing that we want to know is the equation. So the equation of our parabola could be either a horizontal or a vertical parabola. Now, if we have a horizontal parabola, we have x is equal to 1 over 4p times y minus k squared plus h. And this is often written like this. The actual standard form is x minus h is equal to 1 over 4p times y minus k squared. Oh, put the parentheses in the wrong place. Here we go. And basically all we did here is we just subtracted h on both sides. So we subtract h on both sides, and we now have our standard form x minus h is equal to 1 over 4p times y minus k squared, where your h and your k is still going to be that center, but in this case, because it's a parabola, it's not the center, but it is our vertex. The vertical is the same thing. We have our y is equal to 1 over 4p times x minus h squared plus k. And again, often it is written by subtracting that k on both sides. And then we have our y minus k is now equal to 1 over 4p times x minus h squared. So we can read all the rest of this here, the focus, the directrix, the axis of symmetry, and so on. But I'm just going to show it to you instead of reading it off. So let's go ahead and take a look at a few of these. And what I want you guys to keep in mind is that when we go ahead and write out our equations, when we need to, we're going to write it out in standard form as opposed to the vertex form. And the vertex form is what was typed up. So let's go ahead and take a look at some of these examples, and we'll try to graph these parabolas. So here, again, they gave us our standard form of this equation, and it says y plus 3 is equal to 1 over 8 times x minus 2 squared. And we want to figure out, well, what is the vertex? What is the value of p? What is the axis of symmetry and the focus, as well as the directrix of this parabola? And we can first figure out, well, what is that vertex? That's the first thing that I'm going to look for when it's written in standard form. Now, because it was y minus k, this k is going to be -3. And because it was x minus h, that means h is going to be +2. So the vertex, right away, I know that the vertex is going to be located at HK, which is 2, -3. So I'm going to go ahead and graph that point at 2, -3. That's this point right over here. Now, what I need to do next is I need to figure out, well, where's my focus and where is the directrix? So I got my vertex. Now I need to figure out, well, what is the p-value? Now, according to our format, that p-value was 1 over 4p, which means that 8 is 4p. Now, if that fraction is positive, which it is, that means in this case, it's going to be opening in an upward direction. And I know it's opening up because it said y minus k in the beginning. So it says y plus 3. So that told me it's opening in an upward direction. Well, that means since that 1/8 is a positive, it's opening up. If 1/8 was negative, it's going to open down. Since I know it's opening up, I know that 4p must equal to 8. And well, if I solve for p, that means p has to be 2. So that p, the value of p, is what we just found here. And that value of p is going to help me determine what is the focus and what is the directrix. Now, the p is the distance that focal point and that directrix is away from our vertex. And since it's opening up and the focus has to be inside the parabola, I'm going to go 2 units up from that vertex. So here's our focal point. There's F. And the directrix is 2 units down. Now remember, directrix is a line. So what I'm going to do is I'm going to pull out my straight edge here, and I'm just going to go ahead and draw this straight line going through that point. So what we've just found is the directrix and the focus. So if I were to write all this out, if I had to write it out, the focus is now located at 2, -1, and the directrix is going to be a line, which means it's going to be an equation. And that equation is when y is equal to -5. It's passing through -5 on the y-axis. All right, so now I need to figure out, well, how do I draw my parabola? I want to figure out the rest of my parabola. Before I do that, so we have the focus, we have the directrix, we have the vertex, we found all of that. Now, the other thing that I need is my axis of symmetry. And that axis of symmetry is a line that goes straight through the focus and the vertex. So I'm going to go ahead and draw this line right over here. And that's going to give me my axis of symmetry. So that axis of symmetry is going to be located right over here. Okay, so our axis of symmetry, the AOS, the axis of symmetry, is going to be going through the point at when x is equal to 2. So it's a straight line when x is equal to 2. All right, so I got to draw the rest of my parabola. And because of our definition said any point on our parabola to the focus is going to be the same distance as it is to the directrix. So here's a quick little trick. What I'm going to do is I'm going to go ahead and figure out, well, what is the distance? I'm going to zoom in here so that you can see this. And I'm going to go ahead and figure out, well, what is the distance from the focus to the directrix? And that's 4 units. So what I'm going to do is I'm going to go 4 units to the right, and I'm going to go 4 units to the left. And if I do that, I'm going to have a point right over here, and I'm going to have a point right over here. So I'm going to go 4 to the left and 4 to the right. And that's going to give me 2 other points on our graph. So now that I have this, I could go ahead and kind of sketch out my parabola here. But we can also find additional points. And this is another little trick here. When I have my fraction here in my equation, I see this 8 in the denominator. Well, here's another trick that we can do. From the vertex, I could go 8 units up, 2, 4, 6, 8, and then go 8 units to the right, 2, 4, 6, 8. So here's another point over here, and because it's symmetrical, I could go 8 units to the left, 2, 4, 6, 8. So now I have another point right over here. Okay, so now I have 5 points. I got these 2 points that we found earlier. We have the 2 points that we just found, and we also have our vertex. So I'm going to go ahead and sketch out this parabola the best that I can. And this is what our parabola looks like. All right, so let's go ahead and try another one. And we're going to take a look at one where it's going to be a horizontal parabola. And I know it's a horizontal parabola because it starts off with an x minus h. So we have our x minus 1, so we have that x minus h. So I'm going to write out my h and my k. And my h value here is going to equal to 1. The k value is equal to 3. So I know what the vertex is. The vertex is going to be located at 1, 3. Remember, it's h and then k. So that means my point, my vertex, is going to be located over here. Now again, we already know that it is horizontal because it started off with h. So I'm going to take a look at this fraction here, and this fraction happens to be a positive fraction, which means it should be opening to the right. If it was negative, it's going to open to the left. And that 12 is our 4p. So I need to figure out, well, what is p? So if 4p is equal to 12, that means p must equal to 3. So we know what the value of p is. We know our vertex. And what we're going to do is we're going to use that value of p to help us figure out, well, what is the focus and what is the directrix? So to figure that out, I'm going to go ahead and move 3 units to the left and 3 units to the right. Now, because it's opening to the right, that means the focal point must be inside the parabola, and the directrix is on the other side. So I'm going to go 3 units to the right from the vertex. That's the focus. And I'm going to go 3 units to the left, and that's going to help me determine my directrix. And this time my directrix is opening, or is going straight up and down. So here's my directrix. Okay, so now that I have my directrix, I'm going to go ahead and draw my arrows. It does go on forever. I have my focus. The focus is located at, it looks like 2, 4, 4 to the right, and then up 3, so at 4, 3. And the directrix is located at x is equal to -2. Okay, so once again, what I want to do is I want to figure out my axis of symmetry. And again, the axis of symmetry is a line that connects both the focus and the vertex. So here's my axis of symmetry. My axis of symmetry is going to be located at y is equal to 3. Okay, so we got the axis of symmetry, we got the focus, we got the directrix. Now all we got to do is finish off this graph. And again, what we're going to do is I'm going to go ahead and find 2 additional points. And in order to do that, I want at least 2 additional points. I want to know the distance from the directrix to the focus. And that distance is 6. So in this time, since it's opening to the right, I'm going to go ahead and go up 6 from the focus. So here's 3, here's 6. And then I'm going to go 6 down from the focus. Here's 3, here's 6. Okay. Now, what we could also do, like what I said earlier, remember that 12 in the denominator means that I could go 12 units up from the vertex, and then, or 12 units to the right in this case, and then up and down 12 units again as well. So from the vertex, so from here, I'm going to go up 12. So 2, 4, 6, 8, 10, 12, or to the right 12. And then I'm going to go up 12, 2, 4, 6, 8, 10, 12. So I just barely made that. And then I could go 12 down. 2, 4, 6, 8, 10, 12. So I have several points here, and these points is going to help me draw my parabola. All right, so there's our parabola, there's our graph. Okay, so let's go ahead and take a look at another example. Except this one is a little bit different. This time, what they did is they gave me the focus and they gave me the directrix. And what I need to do is I need to figure out, okay, well, what is the vertex? Come up with the equation and then graph the parabola. All right, so let's take a look at this with the given information here. So the first thing that I know is that they gave me the focus. So I'm going to graph that focus. That focus is right over here, -2, 0. They also told me what the directrix is. And the directrix is x is equal to 2. Well, if it's x is equal to 2, that's right over here. And that means it has to go through that point. So I'm going to go ahead and draw a straight line so that it goes through that point, which means that line should be going up and down. Now this tells me a couple of things. One, it's telling me that this is going to end up being a horizontal parabola because the directrix is going up and down. And I know that my parabola is going to be pointing towards the left because it's always going away from the directrix. So I'm going to go ahead and kind of sketch that out on the side here. So I know that it's going to the left. I know that my focus is somewhere over here, my directrix is somewhere over here, and we know that the vertex has to be somewhere right in the middle. Well, if it's right in the middle, well, the point right in between the vertex and the directrix is right over here. And that point happens to be the origin. So the vertex is going to be located at 0, 0. And that's our h and our k value. Now, we also know that the p-value is the distance from the vertex to the focus. And I'm always going to go ahead and do it to the focus because that's telling me if it's positive or negative. So the distance from the vertex to the focus is going to be -2. So that means p is equal to -2. Okay, so that's some other information that I need. All right, so now I'm going to think about my equation. And my equation is x minus h. I know it's x minus h, it's because it's a horizontal parabola here, is equal to 1 over 4p times y minus k squared. And all I got to do is substitute. I just need a plug and play. So when I go ahead and substitute everything in, well, h is 0 and k is 0, so that means x minus 0, which is just x, is equal to 1 over 4p. Well, p is -2, so 4 times -2 is -8. And I just move that negative sign to the numerator, so -1/8. And y minus 0 is 0, so that means y squared. So here's my equation. X is equal to -1/8 y squared. All right, now all I got to do is finish graphing my parabola. So to finish graphing my parabola, again, I need at least 2 more points other than the vertex. So here's my vertex in yellow. I'm going to go ahead and find at least 2 more points by finding the total distance from here to here, from my focus to the directrix, which is 4 units. So that means I'm going to go 4 units up, 4 units down. And again, if I want some more additional points, I could take a look at my denominator, which is 8, which means I'm going to go 8 units from the vertex. So I'm going to go 8 units from the vertex, 2, 4, 6, 8. And then from here, I'm going to go 8 units up, 2, 4, 6, 8. And then I'm going to go 8 units down, 2, 4, 6, 8. And then I take my pencil and I just draw my parabola. So my parabola is going to look something like this, going in both directions here. And again, they didn't ask for it this time, but I'm still going to put it in. If I wanted my axis of symmetry, that axis of symmetry must go through both the vertex and that focus. And here's our axis of symmetry. And the axis of symmetry is going to be y is equal to 0. All right, so that wasn't too bad. We're just going to take the information that we know, we'll plot it in, And then we'll go ahead and see what the rest of the graph looks like. So let's take a look at this one. Same thing. Here we know what is the focus. The focus is at 2, 3. And we know what the directrix is. So I'm going to start off with that focus. That focus is at 2, 3. So that 2, 3 is going to be right over here. So there's our focus. And we have our directrix. And the directrix is at y is equal to 1. Well, that means y is equal to 1, which is right over here. So that means I'm just going to take my straight edge and I'm going to draw a line so that it goes through that point, y is equal to 1. Okay, so again, this tells me a couple of things. This has to be a parabola opening in an upward direction. The focus has to be on the inside, the directrix has to be on the opposite side, and that means the vertex is right here in the middle. So right in the middle, if I zoom in here, here's our vertex. There's our vertex. Now that point is located at 2, 2. So I'm going to go ahead and write out that ordered pair. Okay, so now I want to figure out what is our p-value. Well, we could easily see that right here. It is the distance from the vertex to the focus, and that's going to be 1. So that means p is equal to 1. So I'm going to use that information. So again, we know that this is a vertical parabola. It's opening in an upward direction. So that means it starts off with y minus k is equal to 1 over 4p times x minus h squared. And we know that our h and our k value is going to be our 2 and our 2. And all you got to do is substitute everything in. So every equation has that y and that x. So I keep my y, and it says minus k, well k is 2, is equal to 1 over 4 times p, and p is 1, so 4 times 1 is just 4, times x minus h, which is 2 squared. There's our equation. Okay, so let's go ahead and finish up with the rest of our graph here. I'm going to go ahead and draw the rest. And again, to draw the rest of my graph, I want to know what is the distance from the focus to the vertex. The focus to the directrix, and that's obviously 2 units. I'm going to go 2 units to the right from the focus, 2 units to the left from the focus. We could go ahead and use our denominator to find more points. So from the vertex, I'm going to go up 4 to 4. Try that again. 2, 4. And then I'm going to go 4 units to the right, 2, 4, and 4 units to the left, 2, 4. And that's going to give me enough information for me to draw my parabola. So starting from the vertex, remember it's coming from the vertex. It's opening up to the left and to the right. Okay, so the last thing that I need here is going to be my axis of symmetry. Oops, let's get rid of that. So that axis of symmetry has to go through both the focus and the vertex. Let's change the color here. Back to yellow. So here's our axis of symmetry. We'll go ahead and put in our arrows here. And the axis of symmetry in this case is when x is equal to 2. Okay, not too bad. All right, I hope you're getting this. Let's try one more, one last one. Make sure we got it. All right, same thing, it's just written a little bit differently, but pretty much the same exact thing. If you want to pause the video and try it on your own, by all means, go for it. All right, while you're doing that, I'm going to go ahead and get started on mine. So let's go ahead and take a look at what we have here. We have our focus. The focus is at -3, -1. So left 3, down 1. There's the focal point. The directrix is going to be located when x is equal to 1. So when x is equal to 1, that's right over here, and that's where I go ahead and draw my straight line. So I'm going to go ahead and draw my straight line so that it goes through that point. And right away I can see that this is a parabola. It's a horizontal parabola, and it's opening towards that's right, to the left. So it's opening towards the left because that focus must be contained inside our parabola. So here's our focus. The directrix is on the opposite side. That means the vertex is somewhere right in the middle. So our vertex must be right over here. And that vertex is located at -2, -1. So I'm going to go ahead and write that out. -2, -1. Here's our vertex. All right. So now that I have my vertex at -2, -1. Oh, I'm sorry. That looks like -1, -1. Let's see here. So we got our x and our y-axis. It's kind of hard to see our x and our y-axis. That should be at -1, -1. Okay. All right. So now we got -1, -1. All right. Now that we made that correction, we now know what is our h and our k. We can go ahead and figure out our p-value. Now remember, the p-value is the direction is going towards the focus. Since it's going to the left, the p-value is going to be -2. All right. We do know that this equation is a horizontal, so that means x minus h is equal to 1 over 4p times y minus k squared. So I'm going to go ahead and substitute everything in. We know that h is -1, k is -1, so that makes things a lot easier. Well, x minus a -1 means +1 is equal to 1 over 4 times -2, so that's -8. I'll throw the negative sign in the numerator. Y minus -1 means +1, and then we have our squared. And again, let's go ahead and graph the rest of our parabola. And we're going to take a look at the distance from the focus to the directrix, which is a total of 4 units. So I'm going to go 4 units up to 4 from the focus, 2 units down from the focus. And again, we could take a look at that denominator that we had here, that 8, and we're going to go from the vertex 8 units up, 2, 4, 6, 8, and we'll go 8 units up and down, 2, 4, 6, 8, 2, 4, 6, 8, and then we'll draw the rest of our graph. And the last thing that we need is our axis of symmetry. So I'll pull out my ruler. We'll just draw that straight line going through the focus and the vertex. And our axis of symmetry is going to be going through the y, so y is equal to -1. That's the axis of symmetry. All right, so now we know how to graph our parabolas, whether they're horizontal or vertical. We know how to figure out what is the vertex, the focus, the directrix, and the axis of symmetry. I hope this video helped, and if you have any other comments or questions, go ahead and leave a comment below. Have a good one.